I'm Ian Hall, and I'm the Chief Technology Officer for IGS. I think probably one of the most interesting projects that I've worked on personally is an inquiry that came up over the telephone. There was an urgent call that we got out of a high-level business meeting in the Middle East, and somebody who had had a lot of experience with before suddenly became aware of a problem and thought that IGS may have a unique solution. And the problem was that they were constructing a large stainless steel pipe section, about 1 inch thick stainless steel material, about 60 inches in diameter. And these sections were all being welded together. And initially there was no concern about that method of construction. But one of the things that happens when you weld large sections of pipe together, or any large section of steel together, is that welding process damages the adjacent material. And particularly with stainless steel, you can get what's called sensitization of the stainless steel. And if your chemical process flowing through that pipeline is corrosive enough, it can cause damage and potentially rupture to that area. The solutions that were available were not great ones. They were slow and they were expensive. But the gentleman who brought the opportunity to us remembered that we had used this technology to protect vessels before, and got on the phone to us and asked us whether we'd be able to assist them. And to cut a long story short, we developed the HVTS technology to apply a band of HVTS cladding to each of those weld seams in this very, very large pipe section while it was being constructed, to ensure that the weld and the area either side of it was being protected. So from an application point of view, it seemed quite simple. We could just apply HVTS cladding to the inside of these weld seams and move on. But one of the challenges that we had is, because it was stainless steel, it wasn't easy to measure the thickness of the cladding that we were putting down. So we had to develop some very unique automations and mechanical systems that protected the area that was being clad, and then some laser profilometry tools that could measure the profile of the material that we were putting down, so we could digitally measure exactly how much material was being put down to ensure that the entire area had been protected. So that was good, and all the work was completed. But a key need was how were they going to verify that the technology was still delivering, was still working, was still protecting the weld seam. And fortunately, about 2 years before, we had just developed another technology, which is a means of inspecting the internal integrity of a thermal spray cladding from outside the vessel. And we could apply this to the pipeline as well. So we were able to come back after the construction had been completed and do external inspections and still be able to determine that the cladding system inside was still had good integrity, was still in place, and everything was functioning well. So a very different project. It was a pipeline instead of a vessel. It was thick stainless steel, a very unique need, but it just came out of a conversation and something that somebody remembered in a meeting, and IGS delivered a unique technical package to solve that problem.